several different ways to change the color of wood if you don't like what you have. Perhaps the most common is to use a pigment stain. This is actually a paint pigment, a powdered colored chemical, mixed in a thinned varnish or some sort of keeper that will glue this to the surface, and it changes the color by creating a light wash, a paint that is so thin you can actually see through. The next way you could do it is with a dye. This is an aniline dye that I've mixed up and stored here. It actually comes in a powder form. It's liquid when it's mixed up, and it goes on and soaks into the wood fibers and bonds with the fibers. Much the same way a dye that colors your clothes will bond with the cotton fibers. In fact, they're the same chemical. The dye, because it soaks down into the wood, is a deeper and more vibrant color. It doesn't disguise the wood grain as much as the pigment does. Finally, there's chemical stains. You can apply a chemical to the wood that reacts with another chemical in the wood, and this reaction will sometimes cause a change in color. Now, both pigment stains and dye stains depend upon the wood grain and the density of the wood for how they look when you apply them. Let's take this piece of yellow pine right here. The dark bands are the summer wood. The light bands are the spring wood. The spring wood is where the wood starts to grow in the springtime. It grows very fast. This is not very dense. In the summer, it begins to slow down, and it gets denser and denser and denser until on pine, this summer wood can actually be denser than ebony. Because this is an inconsistent surface, it won't take the stain or the dye consistently. If I apply the pigment stain, it will lay more on the softer wood than it will the harder wood. The same way with the dye. It will soak into the less dense wood faster than it will soak into the dense wood. So what's going to happen is that the summer wood will end up having a lot of pigment or a lot of dye. The spring wood will. The summer wood won't have hardly any. And you'll actually get a reverse effect here. What now appears to you to be dark will be light, and what appears to be light will be dark. Here, I'll show you real quickly with a little bit of dye here. Let's see, I'm going to need that. I got another one back there. Going to be hard to get this. There we go. Now if you could come into that, let me turn it in the light. See that? I put on an ebony stain on this, and the dark bands became light, and the light bands became dark. It'll look awful when it's done. The nice thing about a chemical stain is usually the chemical that you've put on the chemical that in the wood that it reacts with the chemical that you're applying is pretty evenly distributed. A lot of times chemical stains react with tannin. Oak has a lot of tannin, so does cherry, walnut, tannic acid, and as a result, there's certain because the tannic acid is fairly evenly distributed in the wood, the color that results from the chemical reaction will also be fairly even. The chemical I'm going to show you, though, actually reacts with a much more basic chemical in the wood. This is nitric acid, and the nitric acid is a favorite of gunsmiths. They used it for a long time to darken their wood stocks. The nitric acid actually reacts with the cellulose and causes the cellulose to oxidize. Now you can see this. I'm going to step out of the frame for a minute and get something that I built a long time ago. Well, not that long ago. This is a train, or the engine of a train, that I made for the second issue of Hands-On magazine. It was made out of poplar, and when I first made it, it was this light. Okay, there's a piece of poplar that I just planed today. Now I have not put any stain on this poplar. I haven't put anything but a tung oil finish. But over about 27 years, this wood has slowly oxidized, and it has created a patina. The patina is a good deal darker than the wood started out to be. So what nitric acid does then is it simply speeds up the process of oxidization and creates an artificial patina. If you go to buy nitric acid, you'll be faced with a decision. They'll ask you if you want to buy industrial nitric acid, which is about 43% straight HNO3, or you can get laboratory grade, which is about 70% nitric acid. I'd go for the laboratory grade, and the reason is because if you get the industrial strength, you'll have to buy it in a 55-gallon drum. The laboratory grade you can buy by the gallon, and I have about a quart and a half left in this gallon, and the last time I bought a gallon of this stuff was about 20 years ago. It goes a long way. If you're going to use nitric acid, it is an acid. You want to wear rubber gloves. I'm also going to wear a face shield here. It's not a particularly strong acid. It isn't as dangerous as, say, carbonated acid, hydrochloricals, or furic acids. This acid was used quite a bit in the gold industry. Assayers would use this to test gold and silver to see how much of the metals were in a particular ore. And they used to use it without any gloves, and if you look at pictures of those old mining camps from way back, you'll see that you can tell the assayers because those are the ones with the black fingers. I got enough of this ebony stain on my fingers. I don't want to turn them any blacker than they already are. The nitric acid needs to be diluted. If you use it just like it is, there is an enormous gives off a vapor that you really don't want to breathe. So you want to get this down to about a 10% dilution. Because this is laboratory grade, this is 70% HNO3, and if I were to put in, let's say I'll put in 7 ounces of water and then 1 ounce of acid. That should be pretty close to a 10% dilution. Well, actually, no, that's about a 12% dilution. Let me start with the water. Now, here's something else that you need to know, is that when you're mixing acid and water, you always want to add the acid to the water and not the water to the acid. That is extremely important. In fact, they even teach you a little ditty in chemistry class, so they be sure you get it. Add the acid to the water like you oughta. If you don't, if you add the water to the acid, sometimes there's a reaction which causes all the water and the acid to spray, or so it's like a little miniature explosion, except it isn't. But it will bloosh right out of that cup and get all over you. Let me. Something else I want you to notice here. I'm mixing these in glass containers. Okay, it's if you get this acid on metal, it will react, and it will react fairly violently, actually. Let me show you something here. Drew and I mixed up some nitric acid stain a while back, and we had it in a glass ball jar. And we had misplaced the top, so we put a piece of tin foil over the top, and thinking that we'd find the top quickly and replace the tin foil before it got eaten away. Well, best laid plans of mice and men. We forgot about the thing. The tin foil was eaten away. This square was hanging on a magnetic rack right above where the acid was. This wasn't caused by direct contact with the acid. This was caused by just the vapors of the acid evaporating. And as you can see, it is just covered in rust. So the acid oxidizes the metal as well as it will the wood. When you're storing the acid, you also want to store it in a special container, either plastic that is acid proof, or what I have here is the classic way to store acid, and this is a jar with a glass stopper. It's ground glass, and believe it or not, that glass actually makes a tight seal when you put that down there. Now, got this. Let me move everything out of the way here. You need two tools to apply the nitric acid stain. The first, you need a brush, and I'm using a rubber brush simply because there are no metal parts in here. You really don't want to use a brush with a metal ferrule. The acid will eventually eat this brush up, but it'll last long enough to do a good-sized project before it falls apart. I also need a heat gun. This will not work without a heat gun. I show this trick to a lot of people, and they think, well, can I just apply the acid and wait? Well, what happens if you apply the acid and wait, what you get is a green, blotchy surface after a while. So let me take some acid and wipe it on the wood, and then just let it soak in. Now, because this is a water-based stain, basically, it may be a good idea to wipe the project down first with some water. Take a wet rag, wipe it, let it dry, and then sand it with whatever was the last grit that you used. For example, if you stopped with 220, let the wood dry completely, and then knock off what'll feel to you like little peach fuzz. These are actually fibers that are standing up. Knock those off with 220. Then your application of nitric acid shouldn't raise the fibers too much after that. Now this is soaked in. I'm going to take the heat gun, put it on high. Now this board that I've applied the acid to is actually made up of 6 species of wood. That's where I am right now. That's pine. This is mahogany. This is maple. That's cherry. walnut, and finally oak. And you can see with an application of heat, the color develops. It's a very similar, the way this color is developing is very similar to what happens when photographers used to develop pictures with chemicals. They would expose a sheet of paper, photographic paper, to light, throw it in the developer, and in a couple seconds, all of a sudden, the picture would come up. And that's just what's happening here. All of a sudden, the color comes up. As it heats up to a certain point, the reaction begins, and the surface oxidizes. There you go. Pretty cool, huh? And it's dead even across all of those. It creates a nice nut brown. There's no blotchiness to it at all. Where there appears to be a little bit of blotchiness, right here in the oak, that's actually I haven't evaporated all the acid. Now, some woodworkers add a third step. They apply a mild dilution of sodium bicarbonate and water to this to neutralize the acid. I have never found that to be necessary. The acid has gone in, it has reacted with the wood, the reaction is over, the acid is neutralized right now. I have put all sorts of finishes on top of this, and the finishes always come out just fine. And the acid or the residue that left over from the acid doesn't seem to interfere with tung oil, polyurethane, acrylics, and a half a dozen others that I've used. If you do find that you get a reaction with this wood once you've treated it, all you have to do is coat it with a single coat of clear shellac, white shellac, and then put whatever finish you want on top of that. I want to show you something else about this finish. Not only is it dead even, but watch this. I'm going to take and make another streak right across there and give it a minute or two here to soak in. And what you'll see is that there will be no lap marks. Those of you who have worked with aniline dyes on wood know that lap marks can be a terrible problem, especially if you're using an alcohol-based dye. They can also be a problem with some pigment stains also, but you get absolutely none of that here. There you go. No lap marks now. There's a little bit of moisture right there that I haven't quite got yet. But once it's gone, there will be nothing. It'll be dead even. Now that is really the value of this stain. Let me show you. First of all, on the opposite side of this board, let's go back to the close-up camera here for a minute. On the opposite side of this board, I've done a series of stains just so you can compare them. The stain up at the top of the board is a pigment stain. And you can see that it works on some pieces and not so well on others. Here in the oak, it really brings out the grain over much. Over here on the pine, it's splotchy. This is a golden oak dye right here in the middle. And Again, it works some places and it doesn't work others. It seems to work on more of the woods than the pigment stain, but it does get a little splotchy on the pines. And then finally, at the bottom, you have the nitric acid, and it is just totally even all the way across. It works well even on problem woods, such as this poplar. Anybody who's ever tried to stain poplar and has lived to tell about it usually has a horror story. But here, there you go. Beautiful reddish brown. It's kind of like the poor man's cherry. Very, very pretty color. Now, just to really, really stretch the limit, this is a piece of construction-grade fir plywood. There is nothing uglier in all the world than somebody who has tried, or a piece of plywood that someone has tried to stain. Not only that, this is the C side of the plywood. This isn't even the good stuff. Over here on the good side, I've experimented, just so you can see, with a little bit of pigment stain and a little bit of golden oak dye, and both stains just look awful. Now we're going to take on the C side, the bad side, the side that you'd turn away from everybody. Now put a little nitric acid. Count to 10 and go. There you go, on the surface, surface where I got it a little too wet there at the top, but here on where I've applied it evenly, it's nice and even. That'll work for almost any project. It's a very versatile stain. It's good for turning inexpensive woods into rich-looking woods. It's good for woods that do not normally take a stain evenly, and it's great for repairing antiques. Lots of times you'll take a finish off an antique, sand it, accidentally go through the patina. You can put a new patina on with a little application of nitric acid and some heat. What it's not good for is it's not good for figured woods, curly maple, bird's eye maple, anything with a burl or a curl in it. Because it is so even, it actually mutes those effects. You would be much better off using a dye with something like that. That's all I have to say about that.